All right, in this video, what we're going to do is we're going to go over this first free response question from the Unit 6 review. So hopefully you've had a chance to read it. This is a real free response question, I believe, from 2011 AP exam, so a long time ago, but still very applicable. We've got two groups. All right, we've got both of these groups have men that have high cholesterol readings. They're middle-aged males, 20, so 10 in each group. They're randomly assigning them to either be group A, where they get a placebo. So remember, that's a sugar pill, so it looks like the real thing, but is not actually the same drug. And then group B, where they're actually getting the cholesterol drugs. We want to see at the alpha level of 0.01. So they actually give us an alpha level here. Is this cholesterol drug effective in producing a reduction in the mean cholesterol level beyond that just produced by exercise and diet? So we're going to be running a test. My first thought is, because we're talking about means, we're talking about the T model, so I have to decide with these two groups, is there a link between them? And it doesn't say that these males are related in any way or they haven't paired them in any way. They're just two separate groups. So what we're going to do is say the groups are independent and do a two-sample t-test. So let's do our first defining the parameters. So let mu sub A represent the average reduction in cholesterol from men in group A. So again, those are the men that are taking the placebo. So same thing, but for group B, so represent the average reduction in cholesterol for men in group B. And remember, in group B, they're getting the actual cholesterol drug. We're hoping it doesn't say, but we're assuming that with the use of the placebo, that control group, essentially we're talking about some type of blinding will need to be going on here. So you got a couple options for your hypotheses. I'm going to do mu sub A minus mu sub B is equal to 0. So notice the order that I did there. So for my alternative, I'm going to do the same order. But if you look, right, we're hoping to prove that the group B, which is getting the actual drug, has a larger average reduction. So if you're subtracting a number that's larger than the number before it, that means we're going to have negative numbers, or excuse me, yes, we're going to have smaller numbers. So let's do less than 0, right? Because if you also look, right, the mean reduction in group A is given to us, the mean reduction in group B is given to us. You can see we have a smaller minus a larger. So we're looking for something to be less than 0. So we will be shading and doing a one-tail test to the left. All right. So let's do our assumptions and conditions. So first assumption is one man's cholesterol reading, or I guess cholesterol level, won't affect others. Now, we know they're all in the high category already, but ultimately, at the same time, we still need to see if they're independent or not. Now, for the other assumption, and you can do the independent groups assumption here if you want. You don't have to. It's up to you if you want to do it now. I'm going to wait till the end, but you can do it now if you want. The order doesn't matter. We do need to check randomness. It does say that they were randomly assigned, right? Randomly assigned to each group. So subjects were randomly assigned, so that's good. And it's kind of like not really that important to do the 10% condition here, just because ultimately we're talking about getting men that would fit into this category. If you did it, you would obviously be able to find more than 100 men that fall into this category of being middle-aged with high cholesterol. All right, so that's not an issue. All right, so let's move to the normal population assumption. So we would assume that the population histogram would be normal. All right, and we don't know if that's true, so what we do is we check the histograms for each of these groups. So I have them in my list 4 and 5. Once my calculator turns on here. Come on, calculator. Give it a second. There we go. So I'm going to go to my second stat plot. I've already got this one on. I was doing some work earlier today, but I'm going to change this to list 4. So this is my group A, and do zoom 9. And it looks unimodal with potential skewness. So let me sketch group A over here. So we've got group A, look at it again. Okay. We've got here, then a little higher, and then we've got 3 lower ones. Okay, and this is our group A. All right, I'm going to sketch group B. So do the same thing, but they're in my list 5. Okay, oh, that one looks incredible. Actually, it looks perfectly symmetric. Wow, that's amazing. Let's see, okay. Now, one thing I do notice in my group B, even though it almost looks exactly symmetrical. One thing I will mention is if you notice, it's the only one that has a negative, which means that for this man, whoever it was, after doing the regimen or however it takes, it doesn't say, or maybe it does say and I just missed it, but after taking the drug for a certain amount of time and doing the exercise and diet, there it is, 3 months. I knew it would be somewhere. After 3 months, this man, actually his cholesterol went up. So that's something that I would be a little concerned about. Yes, I know the overall average mean reduction was greater than Group A for Group B, but ultimately they were the only one that had a man actually his cholesterol went up. So I'm going to say the histogram for Group A shows some skewness, but Group B is unimodal and roughly symmetric. So once you get to this point, all right, what you want to do is you want to go ahead and do your independent groups assumption, and then do your statement to say what you're going to do. So what we're going to do here is we're going to say that the two groups are independent of each other. Okay, so now I'm going to say the conditions have been satisfied. So I will use the T model with, and I don't know how many degrees of freedom, right? Remember, with 2 sample t-tests, ultimately we have to wait till we use the technology. So I'm going to leave a little blank there. Degrees of freedom to run a 2 sample t-test. All right, so let's write down all the stuff that we know. We know the sample size for group A is 10, same thing with B. We don't know, actually we do know the Y bars for A and B. They were given to us, that's kind of nice. So I have 10.2, trying to think what the units were, has it up here, milligrams per deciliter. And then the other one is 16.4 milligrams per deciliter. The standard deviation is there as well for both. So we'll write down 7.66 milligrams per deciliter, and I believe it's 9.4. Okay, so we're ready to do our formula to find our t-test statistic. I don't know the degrees of freedom. I'm going to subtract 10.2 minus 16.4. Remember, if you did the other order, that's fine. Just make sure that when you do this, you'd have to do a one-tail test to the right, so your symbol will be different. You'd have greater than, right? So it's that minus 0 over, and our standard error is going to be the standard deviation for the first one squared over the sample size plus standard deviation of the second one squared over the sample size. Okay. I'm going to go to my calculator. You actually have an option here because it does give you the data and it also gives you the statistics. So if you wanted to, you could do stats. It's all there, right there. I've already got them in my list 4 and list 5. So I'm going to go ahead and just use the data, but it's up to you. You should get the same thing. And my symbol, I'm going to confirm, but I'm pretty sure I used less than in my alternative. I did, so I'm using less than. I'm not pooling, and I'm ready to calculate. All right, so our test statistic is negative 1.618. Negative 1.618. Let's find our degrees of freedom, which is essentially 17.296. So 17.296. I'm going to draw a quick little curve out here, shading at t equals negative 1.618, shading to the left. And this p-value is 0.062. All right, so that's my p-value. Okay, comparing that to the alpha we normally use of 0.05, you can still see that the p-value is above alpha, but the alpha they wanted was an alpha of 0.01, and it's definitely not below that. So our p-value, so I'll start here, our p-value is above 0.01, so I will fail to reject the null hypothesis. All right, and then this is where I just use the question to answer, right? At this time, right, literally just use the paper. We're going to say at this time, the cholesterol drug is not effective in producing a reduction in mean cholesterol level beyond that produced by exercise and diet. The cholesterol, let's try to spell that right, cholesterol drug is not effective in producing a reduction in mean cholesterol level beyond that of diet and exercise. And that is it. We did it. All right. Again, the hope is to do this in between 10 to 15 minutes. And we were able to answer this. The video is exactly, in here a moment, 13 minutes. Good job, guys.